Alright, welcome back to Mr. P Helps with the Algebra 2. This is Unit 1, Topic 3, SLT number 20. So we're going to get into graphing exponential functions and their inverses, which we now know are called logarithmic functions. What is the domain and range of f of x? So let's say it's 2 to the power of x. So first thing we need to do is we need to graph it. Now I don't have a clear-cut x and y axis. Sorry, so what if x is 0? 2 to the 0th power is 1. So 0, 1. If x is 1, 2 to the second is 2 to the first is 1. Sorry, 2 to the first is 2. 2 to the second is 4, and so forth. Now this has an asymptote of 0 because really it's plus or minus nothing. So I'm going to draw a horizontal line right here at 0, wherever that x-axis is. And that's the asymptote that it's never going to hit. And it's going to go something like this. Now, the inverse of this function is this 0, 1, it'd be 1, 0, which is right here. This is 1, 2 becomes 2. This is 1, 2 becomes 2, 1. And this is 2, 4 becomes 4, 2. 2, 4 becomes 4, 2. 1, 2, 3, 4, 1, 2. Okay, so in this case, it's going to go like this. Now, this one also has an asymptote of 0, but it has a vertical asymptote. So this equation kind of goes like this, and you'll notice that these two inverses, just like all the other inverses, are just a reflection over the y equals x. If you take this and you do a mirror image onto the other side of the y equals x, it would turn into the pink one. Alright, so inverses. If f of 3 is 8, then what is f inverse? What's the inverse f of 8? So that would have to be 3, because what we know about inverses is that the x and the y's are the same thing, just switched. If f of 1/2 is this number, then what's the inverse f of this? That would have to be 1/2, because that's the inverse of this. You just take the x and the y, and you switch them. Okay, so given that 10 to the x, okay, so I'll try to do a little bit better job this time. So there's my axes right there and there. Okay, that looks better. 10 to the power of x. Well, first of all, it has an asymptote of 0 because it's 10 to the power of x plus nothing. There is no translation moving it up or down. 10 to the power of 0 would be 1. Anything to the power of 0 is 1. 10 to the power of 1 would be 10, so that'd be something like up here. So then you've got your graph. Okay, I kind of missed, but you get the idea. It's going to look a lot like the last one, but it's going to go up much, much quicker. It's still got this 0 asymptote that it's never going to hit, because if you go this way, 1/10, 1/10, 1/10, 1/10, 1/10, you're never going to have nothing. So it's kind of like if you take a candy bar and you split it in half an infinite amount of times, you're still going to always have something. It's never going to end up being nothing. It's never going to have a height of nothing. The domain in this case will be all real numbers. The range, it does not go below 0, so it would have to be everything that's greater than 0. So now let's talk inverse. The inverse has an asymptote of 0 also, but it's a vertical asymptote. This is 0, 1 becomes 1, 0. This is 1, 10 becomes 10, 1. And it's going to look something like this. And once again, that is a reflection over the y equals x. Alright, so this would have this one, the inverse, would have a domain that does not go left and right infinitely. It does go left and right infinitely. Okay, so that's kind of a mistake. But it goes right infinitely, hitting all numbers to the right. But it's not going to go left infinitely in the manner of the fact that it's going to hit any of these negative numbers. So x has to be everything greater than 0, because it's never going to get to the left-hand side or going to hit that vertical asymptote. So the range in this case, this is going up infinitely and down infinitely. It will hit all numbers going up and down. So notice that the domain and ranges are basically switched, because that's what inverses do. Alright, so what if it's e? Alright, I'm not going to take too much time graphing this one, because this is kind of similar to the one we had already done. E, as we learned in previous lessons, is about 2.718. So this would be 0, 1, because anything to the 0th power is 1, anything to the first power is itself. So it would be about 2.718. Now this is not going to change too much from 2. 2 to the power of x And 2.718 to the power of x isn't going to change very much. This one's going to go up just slightly faster than the other one. And all of its domain and range is going to be exactly the same. And then this is going to have a vertical asymptote and looks very similar. Okay, I really messed that up. Let me try that one again. So it's going to be real close to the asymptote and then go up fast, like that. Okay, so this is the logarithmic function that happens to be the inverse of e to the power of x. Okay, and that looks to be it. So, keeping this short, please give it a like to help you learn something about graphing functions and their inverses. This is real basic. When we get into SLT like 23, 24, we'll get into more specifics when it comes to graphing. All right, thanks again for watching. Have a great day.